Hey, Pam.
Morning,
Welcome.
David. Thank you. How are you?
Very good. And how are you?
Not too bad.
That's good. I'm really enjoying the book you suggested, the Master Algorithm. It has some of the best descriptions of all the different types of AI that I've yet seen. So thank you again. I love your books. Please keep them coming.
Yeah, no worries, no worries. The author, Pedro Dominguez, is a character on Twitter, though he's not very well liked. He's very anti-woke, borderline, racist, sexist. Like he puts these provocative posts out. So he's a controversial character, but his science is great. So
yeah, as I say, he actually gave the best description of what was it? The hidden Markov model. Hey, Rob.
Hey, Rob.
I vaguely knew what a hidden Markov model was, but he explained it perfectly, and it's just like, oh, that's what it is. So, yeah. Oh gosh, the full set right on time. Yeah. So I've just been madly editing the document this morning.
Hey, Rose.
Good morning.
Yeah. So how are we all doing? Is anyone going away other than me for holidays?
Yeah, I'm going at the end of the month.
End of the month. Okay, great. You going somewhere nice or sorry?
I'm going to Ireland.
Oh, okay. Back to Ireland. What about you, Pam?
I'm taking a week off the week after the Canada Day. So first week of July.
You going anywhere or just going to hang out here in town?
Haven't decided yet. Maybe go to Vancouver Island. We'll see.
It's really nice, yeah. Rob, are you heading out?
No, I'm teaching this summer. It's my busy teaching time. So.
Oh, okay. What courses are you teaching?
I'm teaching a financial risk management class and a machine learning class for MBAs.
Cool. Very good. No, I'm off.
Tell us what you know about financial risk management given the current situation.
Well, I had a conversation actually last night with a senior person at the Fed. And he was, for a Fed person, pretty forthcoming about how they missed a bunch of things.
Huh?
Like inflation.
They missed inflation? Isn't that like their main job?
Well, it used to be before it became climate change and diversity, equity, and inclusion. But yeah, you guys probably didn't realize that those were the most important criteria for the functioning of a financial architecture. Yeah, okay, don't shrug your shoulders too much. But at any rate, so, short answer is the financial markets are the best predictor of the economy that we have.
The bottom line should be, should I keep putting money into my mutual funds or should I stop? I'm not taking it out, but should I put more or should I stop?
No. I would definitely, at this point, I would definitely not stop.
Say that again? Not stop?
Would not stop at this point. No.
Okay.
So I think, from my perspective, if the market falls a bit more, then I'm going to start shifting money I've got in cash back into the market.
It's coming up again. Yeah.
So does anybody else think that large institutions now are basically buying, then waiting for everybody else to buy, then suddenly dropping the market? You don't think they have that power? Because I watch what happens recently and I see popping up constantly on my screen like investor buys, investor sells.
Sure.
And I think when people are seeing that coming at them, it's very hard to just sit there and do nothing.
Yeah, so that's one of the things, yeah, as an investor, you got to learn how to do is kind of filter out the noise.
I guess I'm saying more than that, though. I think that people are playing the system and they're controlling the system.
I certainly wouldn't rule it out. It would take an unusual sort of coordination among big players to try and make that impactful kind of on a market basis. If they wanted to do it on an individual stock, you know, a game stock or an AMC, you know, these so-called meme stocks, yeah, you can do it there clearly. But the really the big player that influences the market are governments and how they intervene. And the primary reason for that is, you know, if they're going to drop 100 million or $1 billion doing something, they don't really care.
Mm.
And that's part of the reason we've got to the problems that we have now.
I guess one difference could be your time scale, right? Like investors probably don't want to wait 20 years to cash out, right? They want to make money now. Whereas I don't care about maybe as long as we go back to normal or better in 5 years, I would rather keep investing. But yeah, so that could be a difference.
Yeah, I mean, it is true that investors generally have a shorter time horizon. But, you know, there are a lot of smart people who are predicting, yeah, pretty ugly outcomes going forward. So I would take that as sort of a caution. I would, in general, try and avoid big financial commitments.
To diversify your portfolio is what you're saying?
Well, I mean, yeah, look at it this way. Suppose the value of something you held just fell in half. I don't know, you just bought another house. Okay, if the consequences of that are large, that's going to trigger other things that you kind of want to avoid. So, I mean, you know, right now, if you're looking for houses, yeah, I would not buy a house at these inflated prices. Because I think the likelihood is they're going to come down, you know, probably not by a huge amount, but by some. I don't know what inflation is running in Canada. I suspect it's a little bit below the US.
Food is going up astronomically.
And in general, the reported inflation numbers underestimate what's really going on.
Yeah. So now we notice it in our daily spending that things that, you know, like we have our little laundry list of the things that we buy each day, and the food is the biggest shocker in our area. How much would you say it's gone up, Pam? Double for the last couple of years?
Yeah,
Double, you think?
I think it's close to that actually.
Wow,
Yeah.
that's more than we have here.
Oh,
Not everything. Some things have gone quite a bit, like even food items. Some things are a little bit up. So I don't know on average what it ends up
I'm
being.
just saying, like you go to a restaurant and you buy a meal, it's double what it was a couple of years ago. Pretty close.
I don't know about you guys, but every time I go to a restaurant, it's kind of like, you know, even regardless of the price, you know, the service is sort of under par, and oftentimes the quality of food is not as good, and so you're kind of thinking,
People are just bummed out, I think. Like nobody wants to, somehow everybody's just depressed. But I noticed like in restaurants, everywhere you go to interact with people, people are just not very energetic.
I mean, I feel really sorry for restaurant owners because I think it's such a difficult, like making it through the pandemic and then struggling with service workers and stuff, but some of the things they're doing, like I went out with the kids, it was somebody's birthday a couple of weeks ago, and we go to this restaurant, and it was like when you come in, they're just like point you to the QR code, and then like just, you know, put your orders in and we'll bring them to you, but they would only allow you to order 5 things at a time. And they were like, I have 4 kids. And so it was just like so frustrating. And I was just like, I'm sorry, I just can't do this. Like, am I really that old that I can't manage to order? But it was like, come on, like I have some level of service. Like, fine if you want us to order online, but like, allow us to order. Don't have these restrictions. And it was all, I think what they were doing was trying to manage what was happening in the kitchen and manage the people bringing the food out by restricting what the customer could order. But it just felt like it was such a self-defeating thing. It's like, okay, well, I guess I'm just not going to order at all.
My own visions of what's going on, but yeah. We're learning to coexist with our algorithms.
Yeah, or not.
So at any rate, I mean, you know, we're not here to talk about economic stuff, but I would advise a certain amount of caution in commitments going forward. I think you know, again, I don't know so much about Canada, but here in the US, you know, people are basically scaling back. I anticipate that our second quarter GDP is again going to be negative. So that meets sort of the common threshold of a recession, 2 consecutive quarters of negative GDP growth.
But the prices in the market have already factored that in, right? Or do you think that's going to come as a shock and it's going to be another drop?
You mean the financial prices, stock prices and stuff?
Yeah.
I think in general, it's factored in. It may not be fully factored in, and there may be sort of an overreaction that emerges at some point. In the US market, at least, I haven't seen. Okay, so people who have characterized these types of events before say that there's some sort of, you know, cathartic peak where people finally say, screw it, get me out. And we came, I mean, that sort of happened in March of 20 with the pandemic, you know, because
what just happened with crypto? Crypto's in free fall.
Yeah, so that could be a good example too. I mean, I haven't followed that market because it's a little odd to me.
It's gone. I'm not a crypto guy, but I know people who went completely wild on crypto and quit their jobs, and yeah, well, I guess they made their money, but hopefully they got out, because if they're deeply invested now, they lost it all. So, yeah.
Well, somebody's made money and somebody's gotten out.
A bigger fool, yeah.
But in any event, yeah, just you know, be kind of cautious. Don't get overextended. I think things are probably going to get ugly, and I don't know. I can, you know, in the markets here, maybe another 5 or 10% down, and I'll start moving money back into it. But having said that, it could go down a lot more.
This is another valuable lesson about coming closer to retirement age. I know my father-in-law at one point in time was like being so aggressive with his investing, because he didn't want to like listen to like, well, you're going to need this money in the short term. And it's like, well, the market keeps going up. Like, why wouldn't I just invest in individual stocks? And it's like, well,
yeah, I mean, a lot of those individual stocks have really gotten creamed. So part of what the market is saying is that it anticipates rougher times ahead. And so for companies that are not on really solid financial conditions, foundations, they're at risk of going under.
Mhm.
And
Yeah,
yeah, I own some of those too.
On the positive side of things, like a lot of the companies that are super successful now came out of the recession, the previous recessions, right? Like it's a good way to start a company at the tail end of the recession. I think good time to start a company.
Yeah, I think so too. And I think, one of the characteristics I think is that some of the companies that are going to benefit are those that have the ability to kind of pick up the pieces, if you will, and have the resources to do that. So unfortunately, we know their names. Apple, Google, Microsoft, whatever.
4 trillion in the bank and counting. Yes.
Yeah, I mean they're going to be beneficiaries of this. It's my assessment.
They have huge cash reserves. Right. Well, should we jump in and do some other stuff, or
Yeah.
Okay.
Sure. Yeah.
Any questions or comments before I kind of start?
Sorry, I didn't read the blurb. So what?
Well, I just rewrote it this morning, so don't worry about it. I can bring it up if you like. Okay, so I'm just going to give you the kind of the hand wavy thing, and then we'll go from there. So we've been talking about Markov blankets and the stuff from Friston, and I'm trying to come up with a way of blending that with the meme concept. And so I'm trying to create a blended model that incorporates Markov blankets and functions and things like that from a categorical view, and see if we can create higher layers of that take us all the way up to agency. So I'll try and explain what that means. Is it this one? Sorry, one sec. Oh, it's right here in the window. That's it. So, why doesn't it show up in my thing? Sorry, it's not being friendly. Is that it? Sorry, I'm fighting with. It's not showing me my browser window. Oh, sorry, I'm fighting with. That's not it. No, it's not showing me my thing. Okay, I'll try again. I'll try and share my screen again. Sorry. Share screen. Ah, there we go. Sorry, it was not being very friendly. Yeah, so this is possibly complete garbage, so don't set any great store. I'll just kind of take you through the arc. So we start off with soup, and then we have functions in the soup. And so a function, basically takes some part of the soup and consumes some thing in that part of the soup and moves it over there, or transforms it into something else. We can chain the functions together so that A produces, function A produces some X, which is then consumed by function B, which produces some Y, which is then produced by, which is consumed by function C, which is, so we have a chain. Then we can kind of expand that chain into a graph. So this function produces this, which is consumed by these two other functions, which then produce other things, and then they merge together and blah, blah, blah. And so I've kind of got a notional.
Can I interrupt you for a second, just so before you get too far into it, I understand what you're saying. Is function independent of object, or function is what creates an object?
It's a transformation. It is in the categorical sense, it is a map. So given an X, I will give you a Y. It's a lookup table.
Okay, so the X and the Y are the objects.
Yes.
Okay, got it.
And in category theory, it literally is a lookup table where if I give you an X with value 1, you'll give me back this. It's completely predictable. It's a priori. It's just an attribute of the universe.
Great, thank you.
Right, yeah, that's fine. So what I'm saying about a meme, and I'm trying to be as soft as I can, is that it's a function graph that is more likely to form given an existing copy of itself. So given that I have a function graph, which has function A followed by function B followed by function C, the statistical likelihood of that emerging again in the soup is contingent on a precursor, which is itself.
So is that going to wind up being dependent on the characteristic of what the function graph?
Yes, so a given function graph, so yeah, given some soup, we throw some functions into the soup, they stochastically create chains just randomly, but some of those chains promote the creation of copies of themselves, and so their chance of persisting through time is higher than functions that just form for a while and then dissipate. So I'm trying to create a very, very soft definition of a meme that is actually in the mathematical frame, not just a hand-wavy argument. What do you think, Pime? Is that?
Nope, that makes sense.
Okay.
I mean, it's pretty close to, I guess, ideas of evolutionary algorithms, right?
No argument. No. Once again, this is a synthesis. The attempt. There's no novelty here. It's just a synthesis. Can we take these different domains, which have many, many things within them, and try and collapse them down to 7 or so things that we can generate explanations for?
Sounds
I'm not
good.
claiming any of the things we draw in are unique or new. It's just, can we create a coherent kind of simplified worldview that kind of works? I don't know.
Another question, when we say creates an existing copy of itself, is it really a copy or is it similar, very similar? With some, are we talking there are some changes or no changes?
So there's always variation. So it's a matter of degree.
Okay, thank you.
Yeah, it's not a perfect system. No. If it was a perfect system, then you wouldn't get evolution. You just get.
It'll be kind of boring.
You just get a crystalline structure is a mean. Right, a crystalline structure creates more crystalline structure like it. So if I create a cube, then the right binding sites of my cube are one side of the cube, and then I'll get 2 cubes, and then I'll get 3 cubes, and then I'll get salt. So that's what I mean by a more likely to form given a copy of itself, right? So we've talked about protocells before. So that's when you have a complete Markov blanket surrounding some portion of the soup, and that Markov blanket is able to sustain different concentrations and behavior within that soup than the exogenous soup. Same idea. Anyway, this is getting very, very speculative, hand-wavy, so don't put much credibility in this. So a cell is just a protocell that's more likely to form given a copy of itself. Once again, it's a kind of stealing the meme definition. A cell ecology is a set of cells whose likelihood of existence is affected by the presence of other cells. So if there's a cell over there and it's affecting me, then we are part of an ecology. We have an effect on each other. And then we have a eukaryotic cell, which is basically a cell that contains a cell ecology. And then I would argue that ... and then here we would have agent, right? And I don't know what the ... is, and I don't have a good definition for agent, but my goal is to create this kind of tower, if you will, this progression sequence that takes us from a soup and functions all the way up to agency. That's what I was thinking about this week. I'm just curious whether you think that's a useful thing to do or whether it's kind of silly. I'm very open to.
I think the part that I guess maybe we can talk about the ... because I think the definition of agent is actually pretty interesting, because you can draw the lines at any of these steps and call it an agent, and in different scenarios it would make sense and others might not, right? Like you could say a protocell is an agent, or you could say the result of all of these working together is the agent. So like if you take like the immune system, you can say the white cells are the agents, but that's not really true. Immune system is a system, and that's an agent that deals with the problems in your body. Yeah, I guess the definition of agent is very fluid. Like I don't have a good understanding of, I think it's just a matter of engineering what you want to call an agent, except for us humans where we identify with our bodies and ourselves. I think it's really hard to look at stuff in nature and define what an agent is.
I think that's a really interesting question also in terms of like, is the agent part of the system or is the agent observing the system and manipulating it from the outside?
Excellent questions. This is very useful. Thank you. This is very good. I'm thinking about what you're saying. So, okay.
That's a huge debate in like RL people too, like, and they've like professors fight over this stuff. Like if you have multiple agents, can one agent consider all the other agents as part of the environment, or are they just other agents on the same footing and they need to interact? Like, and people go crazy one way or the other. I have no idea what makes sense, but yeah.
Yeah, the layers of abstraction are really important, right? And whether or not we're saying the agent exists on a particular layer of abstraction, or if it's a layer above and it's observing what's happening below. Like it seems like that has to be part of the definition. Whenever you're looking at something, you're looking at it at a particular level. And then are you participating in that or are you outside it? And for the most part, I think the way we think as humans, we kind of see ourselves, at least from a scientific perspective, as almost being outside it. We're looking down on it.
So is agent even the right word? So what Dennett talks about is he talks about the Tower of Mind, right? So you have the Skinnerian mind, which is, don't quote me on this because I can't remember the book perfectly, but there's one level of mind where, you know, what doesn't kill you makes you stronger. You randomly interact with the environment. And if those random interactions improve don't destroy you, then that's a positive thing, but you're not making a plan. You don't have a model of the environment. There's no thinking going on. You have a bunch of functions. They're interacting with the environment and you either dissipate or you don't, right? So there's this kind of there are interventions, stochastic interventions, but and structures that accumulate these biases in the statistical interventions that allow them to persist longer, and so we see them more often. But there's no model of mind. The next layer up, I think he talks about, is the idea of having a model. So in the model, you can run counterfactuals, and then from the counterfactuals that you look at, you can pick the best option to actually execute. And then his final argument is in the Gregorian mind, is that we actually have tools and can utilize these tools to improve our models and improve our understanding of the world. So there are different levels of agency in his mind, and perhaps we should draw those. So we could call this perhaps a Skinnerian agent. Right, so there's different kinds of agents. So this kind of agent is just an intervention system, like a drug that you take, right? It has a certain effect, it does something, but it doesn't reorient itself. It doesn't have a computer inside. It doesn't have a model of the world. It's not releasing drugs based on the level of your hemoglobin or your blood sugar or something. It's just, you take the pill and that's it, right? Whereas you could have a higher level agent. I don't know where they go in this graph, and once again, I'm reluctant to just guess, but does that help? Does differentiating kinds of agency add benefit, or does it just turn the thing into a big mess again?
I think at any point in time, you need to select the level of abstraction that the agent is operating at. Like I think about this in terms of inputs, outputs, or object-oriented stuff, right?
Right.
Like are you in the middle of it seeing everything in the soup beneath, or are you only seeing some abstraction of that?
So it's a hidden Markov model, right? You're
Yeah,
only,
exactly. And so if you're like, that's where we get into trouble, right? Sometimes an intervention will change something in the hidden state that we don't understand.
right.
And so maybe there's a different level of agent that has a different set of interventions or a different set of visibility. It might be on a different level.
Mm-hmm.
So there might be another aspect of the agent that's important too. So one is what you guys are talking about, the level of abstraction that's appropriate for something you care about. The other thing is like we genuinely care about the agents because we are the agents, or something you're building is the agent. So we actually care about the agents so that we make them up. So it is something that it's a primary concern. It's not just a useful abstraction.
Okay. So I'm just going to really stretch it now and kind of throw this out to you. So let's talk about scale separation. So if I have a soup, let's say it's the ocean, and there's a lot of stuff going on there. It's very, very complicated. My argument is that the soup acts as a kind of random number generator. It's a stochastic engine that is generating very, very stochastically generating different concentrations, different structures, different possibilities, different hypotheses. And some of those hypotheses that it generates are persistent in time. In other words, they either build on themselves mimetically or something. And essentially, if there is a scale separation, what you'll see emerging out of that scale separation is agency. So when we have a complex economy that's too complicated to understand, it's an emergent system, what will emerge from that soup is agency. You'll end up having time persisting. You'll end up with creatures from this hierarchy emerging from the soup. And that is the definition of scale separation. So if you have a low-level system and then there is a kind of a boundary, if you like, if you will, a scale boundary, then perhaps what that means is that the only patterns that will emerge from that soup form into one of these structures. That's a kind of crazy hypothesis.
Because I'm a little bit confused. I guess I thought of it the other way around. So that your example of the economy. So you said the agents emerge out of the complex economy. Isn't it the other way around, that agents are there and that their interaction results in an emerging economy?
Could be. I'm trying to understand the symmetry argument that was given by Bronstein in his geometric deep learning. And one of the symmetries that I didn't understand, which I thought was actually quite weak in his presentation, was scale separation. And so if we see agency, we can. So I think you're right, Pine, but I think there's two layers of scale here. So at one layer of scale, we have an emergent system that from which generates agency. And then that agency then forms a new soup at a higher level. And then that creates agency at a higher level and so on. Not sure if that works.
Can you give an example of what you have in mind? What do you mean by generation of agency?
Okay, so we have the ocean. It generated agents like fish. fish have a very, very complicated relationship with other fish, and that's a new kind of soup. And then we have meta-agents, which is schools of fish that emerge from that, complex behaviors or agency emerging out of the components of a lower level soup, which is the individual fish or birds in a flock or predator-prey relationships. These are higher level structures beyond even animals and plants, if you will.
Okay.
Right. So it's this kind of layer
That's
cake.
interesting if you think about fish eating fish and fish eating plants. Like, when is something no longer there anymore, right? If you think of a bigger fish eating a smaller fish,
Right.
it's not that that fish didn't exist, right? It did at one point in time, and it was an object. But then once it's digested, everything is still there, right? But is the fish still there?
Well, the Markov blanket has been dispersed, but the underlying elements have been reorganized into a new Markov blanket. Right.
So tell me about that. I'm not sure I get that.
Okay, so I have a bunch of atoms and I arrange them very carefully to produce a fish. Okay, it's still the same number of atoms. And in order to build that fish, I need to arrange the atoms into these kinds of structures, right? So if I arrange the atoms into these kinds of structures, I'll get a fish. In fact, I'll get a whole series of fish. Those fish are essentially just these structures. They're just memes or cells or protocells or something, right? They are.
See, I don't think it's just structure, because I think there's process involved too, as right. Well as the material fish.
The organization is physical of the various different substrates that allow the functions to progress to sustain the fish through time.
But it's a process that's sustaining the fish as the fish.
That's right. It's an emerging, evolving Markov blanket of possibilities.
Yeah, I think it's called, they call it organized complexity. It's like a complexity, the interaction of a bunch of parts that basically results in some kind of function, and we use that function to classify it as a fish. So once that function disappears, then it's no longer a fish.
Right. So these things kind of come into being for a while and then dissipate back into the soup. Right. So the natural state of the system is soup. And then if you have a soup, then these structures emerge over time, for a time, and then they essentially disperse back into the soup. That's Boltzmann. Right. So this idea of wandering parameters. Anyway. Once again, this is a huge stretch. I'm just wondering if this is even an interesting line of inquiry. That's all.
It's certainly interesting.
Yeah.
Like, I can't get that. Up to now, I've been sort of thinking about it as layers of abstraction, that like the thing still exists at the lower layer of abstraction. But at what point in time does it dissipate? Like, again, think about the big fish eating the small fish. Like, the fish is there. It's now in the mouth. The fish is still there, right? Like, at what moment in time is the fish no longer there?
It's the whole like old argument about the heap of sand, right? You keep removing grains, at which point it's not a heap anymore, right? Like the definition of heap is you came up with it, right? There is no heap of sand. It's a bunch of sand grains, right?
Yeah.
But then what do you do with that, right? When you try and formalize that, what can you do with that? Because it seems like the Markov blankets are going to constantly be breaking down and changing. There is no...
Yeah. Interesting. Hi, Robin. Are you there? Just reaching out. Oh, maybe it's not. Okay. This is just a line of reasoning I've had. I'm just trying once again. So don't put too much store in this. But this is what's emerging from all of my reading, right? Is that there's this progression from these complex, highly interactive, highly interrelated systems that are so stochastically complicated we can't build models of them. We see functions are thrown into this. They move stuff around. As they move stuff around, we start to see sparsity. And when we see sparsity, the soup kind of clears a bit, and we can kind of see a proportion of the soup that's actually fairly simple, and we can build a model of it. We can see that there are function chains. Once again, this is an agent trying to make sense of this. We can see these function graphs as kind of areas of sparsity within the soup, a fish, and so on. So this is about perceiving something that we cannot understand, and the kinds of actors that emerge from that perceptual process, I guess, maybe.
It almost seems like the replicating, like in order to survive, you have to find a way to replicate the level of abstraction you really care about. You need to create other versions of your view of things, or else it doesn't exist.
We don't label singular instances, perhaps. Hi, Robin. Sorry, you're kind of jumping in the middle here, but feel free to listen in.
I'm just going to listen. Yeah, thanks.
Yeah, that's fine. Okay.
Not just labeling, David, but like more than that, you have to propagate the idea forward somehow by creating something self-similar, because if you don't, you'll just disappear.
Right. Yes. So that's what I meant by meme, right? So a function graph that is more likely to form given an existing copy of itself is that replication, a proto-replication. I'm not talking about like full-on reproduction. I'm just saying that, you know, in the presence of a salt grain, more salt is likely to form, right? So you have a seed object, or not even a catalyst, but you have a kind of an initial, like if I have a supersaturated solution, but I don't have a seed, and I put a seed in, then that seed will essentially be mimetic in that other portions of that soup will then essentially adopt the same structure as that meme. Right? So it's not self-replicating, it's not replicating itself, but more copies of itself, or things that are similar to it, are being formed based on its presence. Very soft. There's more explicit forms of reproduction, but this is the softest one I could come up with. So,
yeah, so David, I find this very interesting. I was kind of, based on what you wrote earlier, I was sort of thinking along a similar line, but instead of having, you know, like 7 sub steps there, I had like 2.
okay.
But one of them was sort of in a unsupervised mode, figuring out how to create, you know, some useful clusters or classifications or groups.
Mm-hmm.
And then sort of the next level on top of that is how to use that information that you've created
Mm-hmm.
in some sort of interesting ways. So yeah, I mean, it's kind of like, you know, instead of having 7 steps, I got 2. But one thing that did cause me to stop and think a little bit too is, and this is a point kind of Pam was getting at earlier, one can think of, you know, at some level, all our machine learning models are really kind of descriptive, in that what they do is there's this, you know, function out there that's a characteristic of the observables. And what the machine learning models are really trying to do is uncover a good approximation to that function.
Mm-hmm.
So in that sense, you know, I mean, what they're doing is essentially optimizing. You know, you can look at backward propagation, or in a neural net is that type of process.
They often require a seed object, right? You have to.
Yeah, I mean, okay, so you usually, okay, so, it's a predictive model in that you have labeled data and unlabeled data. And you don't know what the probability density function is of all that stuff.
Mhm.
So you're trying to come up with something that's going to approximate it and therefore enable you to draw some conclusions about how your independent variables drive your response variable.
So 2 comments very quickly. So the way that the DEC unsupervised classifier works is a mean. Okay, so what you do is you say, okay, let's pick some points in the image, right? And then because we've now picked them, it's like dropping the salt grain into the supersaturated solution. If I pick a black pixel, then any dark pixels near me immediately, oh, I'm one of you, okay. And so the mean essentially propagates, and we get the kind of this kind of an effect. Sorry, I was trying to scroll up here. This kind of an effect, right? So as the means propagate, they essentially grow until they hit the boundary of another mean that's also propagating, and that's how we get the unsupervised clusters.
Yeah.
So,
okay. So again, I mean, but the other, let me just kind of keep going with my logic for whatever it's worth.
yeah.
So it seems that of this perspective of sort of having agents, look at their world and try and understand it, if you will, and do stuff with it, really kind of represents a different type of architecture for learning about the world that's very different from what I would classify or what I would characterize machine learning as. In other words, we're not trying to essentially mimic, if you will, a probability distribution of stuff. We're looking at, we got a whole bunch of agents that are interacting with each other, and they're going to do things and interact with each other and do things in a way that's going to produce, some sorts of interesting results.
Mm-hmm. Right.
I don't know if any of this stuff makes any sense, but
no, we're all struggling with that. Trust me. No, I think it makes perfect sense. My interpretation of it is that exactly as you say, I think we anthropomorphize our models. I think that we are looking for agents, we're looking for behaviors, we're looking for human-like stuff in the data that we can resonate with because we have the biological hardware to do that. And that offers us a better than random model of the future. So
I wonder if there is maybe another way of looking at it, connecting it to all the causality stuff we were looking at. Like
sure.
Imagine there's like 2 human beings interacting with each other, right? I mean, there's nothing stopping you from like completely ignoring that these are agents and just keep track of all their interacting atoms and predict what's going to happen in their interaction. Of course, not possible practically, but in principle, that's all there is. There is no agent, there is no human being, it's a bunch of atoms interacting. But once you acknowledge that these are 2 entities, then it's almost like going from your very hyper-connected causal graph and making it sparse, because there are parts in each of those agents that have nothing to do with each other directly. So you can ignore that connection and make some progress in figuring out the interaction. So I think it's just a matter of that, going from assuming everything is connected to assuming that agents basically means a hyper-connected cluster of atoms. And then you can think about the interaction between those clumps.
Right. And we define those clumps in the Friston mechanic of an area of hyperconnected soup surrounded by a Markov blanket, right? And the Markov blanket is kind of the sparse function graph that surrounds the agent. And that's what, and whenever we observe these agents, we have to use a hidden Markov model, right? We cannot observe the SIP directly, because the only way we can observe the SIP is through its Markov blanket, through its, through our outer percepts of its interior. So I agree with you. Yeah, it's very, very relevant. Okay, very cool. So we're coming up on time.
Can you say that again?
Well, I mean, this is just one way of thinking about it. Like,
Yeah.
I'm saying agents don't exist in nature.
Yeah.
Like, they don't, this imaginary construct to help us make sense of things. And so in principle, you can keep track of all the atoms in the universe and, let's say, predict what's going to happen, or to some extent. And you can completely ignore that some of these atoms are highly correlated. We call them objects, and then others are not, right? You can just deal with them individually. That's what physics does, right? There is no agency in physics.
I think if you do that, though, do you lose the process attached to the object? If you just view everything as things, like it's attaching a process to something that gives it the object quality, right? But
that's our definition, right? I mean, it doesn't need to be like that, right? Like, we want to make sense of it.
What I'm saying is, I think if you do what you're saying, you lose all process attached to these objects. All you then have is atoms, and I think you're going to lose too much if you do that.
Because I think it would perfectly preserve all information, right? Like, process is basically interaction between single atoms, right? In some sense, like, we can think of it in a simple Newtonian way. There's a force between every two atoms, right? And the process is just a sort of a combination of all those forces building up on each other or canceling each other out. That's all process is. It's just that if you want to make sense of it in our human brains, then you need to start defining things, classifying things, and making it into a process, right?
But I think as soon as you define it, or it defines itself, something new has been created, and behaviors or processes have come about that wouldn't have come about from the ground up.
You don't think so? I don't know. Maybe you're right. I don't know.
I don't know. I don't think so. I might be wrong, but I don't think so.
Okay, interesting. So essentially, my hand wavy, back to hand waving again. If you have a soup, then there is an astronomical number of configurations that can emerge from that soup, and some of them will persist in time. And if by pure chance one such persistent structure emerges, then it will continue to persist and then have a mimetic effect on the soup itself. In other words, it will attempt to create copies of itself that will deny other self-replicators the chance of emerging stochastically.
Yeah. I'm thinking about this politically, and maybe this is a way to think about what you're saying, Payam, but remember, like, for a while there was this whole thing of like NASCAR dads or six-pack Joes or whatever, and we started to group like voters into demographic buckets that like had never existed before, right? Suddenly you're no longer yourself, or you're no longer your political party or something. Instead, you're this, like, the soccer moms, the evangelicals, the whatever. And then by virtue of creating these definitions, it almost reinforced the behaviors and copied it. Like, that didn't happen from the ground up. That happened because the meme was created in the first place.
And that's actually a perfect point. Like, I just remember, so there's a word for it. They call it downward causation, which is a very controversial topic of, it's like, instead of like our general scientific worldview is reductionism, right? You start with these little things, they build up. But then the question is, do those things that are built up affect what those little things in the bottom do? Which is upward causation. And I think it's a huge sort of philosophical field, which I'm not qualified to talk about. But yeah, I mean, you might very well be right. But I guess it depends on how far down you would go. So maybe it does matter. Like, if you identify as a whatever type of person, it might actually affect your opinions and then resulting in a new way of defining that clump, and it could be a feedback mechanism. But I wonder if you go all the way down to the atoms in the universe, maybe that's not longer true. So I wonder if it's like a
It's
different
true. See, I'm moving the atoms around. I'm doing it. Here I am. I'm moving them.
I don't think so. Like the way I think, like it's like expecting that if we go back to the bits and bytes, we can recreate the concepts that were subsequently represented by them. I don't think we can. I don't think you can ever reverse engineer back up. There's some things that come about that then influence the system that you can't in advance. It's the whole like melting ice cube thing, right? Like how can you determine what the shape of that ice cube would be if you didn't know in advance, right? Once you've seen it, right? And then you see the pool of water, it's like, oh yeah, that makes complete sense. But taking the same pool of water and trying to like say what that would look like, I don't think you can do it.
Just while I've got you, because I know you're going to dash off in a couple of minutes, there is another section. It's very early, but I am actually attempting to do a mathematical breakdown of all of this. So I'm actually trying to build up a mathematical frame. It's very early and it's very bad, but I'm trying to build up a mathematical frame or a mathematical system that allows us to talk about these things in some kind of formal sense. I'm not going to go through that in this meeting, but just if you're interested, you can bring up the document. If you're interested, Robin, I can forward the link to the document to you. It's just a working document we have.
Thanks.
Yeah, okay. Cool, all right. So everyone will be here next week, but when do the holidays kind of kick in? I was hoping that we might go quiet for a little bit, or at least I don't want to have to deal with this when I'm away on my vacation. So do we want to, like, when is the Canada Day weekend? July?
2 weeks.
2 weeks. 2 weeks, yeah. I mean, I can keep going up until the 11th of August, so I've got another month. So
I'm here next week and then I'm gone for 2 weekends.
okay.
So why don't we make next week our last session before the end of summer? How does that sound?
And then close for July.
Is that okay? Well, I'll be away in August, so unfortunately.
Oh, you're away in August.
Yeah, I mean, I'm happy to continue on with a smaller group, but I just realized that a lot of us are going to kind of be in and out. So why don't we just keep on rolling, and if there's not enough people, we'll just call it on a day. I don't know. I'm not trying to shut it down, but I just want to respect that people might want to take a bit of time off. That's all. So,
Yeah, I think I'll be out. I think I'll be traveling on July 2nd, which is a Saturday.
right.
But other than that,
You'll be pretty good.
I'll be pretty good. Yeah.
Okay, so I think we'll just kind of keep going and see how things unfold.
Okay, sounds good.
Excellent.
Great
All right.
weekend, everyone.
So do we want to continue on with this thread? Is this an interesting line to continue on with, or do we? I mean, I'm always open to suggestion. I just put stuff out there just to keep it going. But if you have any ideas or different directions you want to take it, let me know.
I cherish not being in control of the direction, so it's all good.
Excellent.
Nobody's in control.
No.
Right. All you're doing is putting the seed out there and then seeing what grows.
Yeah, exactly. Very good.
All
All right,
right.
folks.
Good to see you again, Robin.
Yeah, it's good to see you again, Robin. I'll forward you a link, and if you want to have a separate catch-up call, just reach out to me, and I can jump on a call with you one-on-one and just kind of bring you up to speed if this is of interest. If not, that's fine too. It's all good.
Bye, guys.
Take care. Bye.